Okay, section 4.1 is all about inverse functions. Okay, so the first thing to note about inverse functions is only one-to-one have inverse functions. So only one-to-one functions have inverses. So it becomes, important then, very important to be able to determine, well, which functions are one-to-one, okay? And so there are different ways to do that. Probably the easiest way is by what we call the vertical line test. So to determine one-to-one, you can, and it's the horizontal line test. So we have the horizontal line test that works like the vertical line test. Okay, and then the other is just using the definition of one-to-one functions. So you need to show that f of A equals f of B then implies A equals B. Okay, so again, we can use the horizontal line test, we can use the definition. All right, and so we'll do a little bit of both of those. All right, so first example, let's say we have, and I'm on page 416, just pick some. So number 14, okay, this function that's pictured, okay, would not be one-to-one. It is not one-to-one because it does not pass the horizontal line test. So the horizontal line test says that if I can find a horizontal line that meets the graph in more than one place, then it's not one-to-one. So again, not one-to-one, okay? It fails the horizontal line test. So it fails the horizontal line test. Okay, and here, the definition really using that is kind of derived from, it's a natural result of this, right? So this is like your f of A right here. Okay, this point right here is your f of B. Okay, so now what you're trying to show is if those things are the same, then A has to equal B, which clearly is not the case here. Okay, and so to illustrate with the definition, let's do number 18. We have y equals 4x plus 20. Now the easiest way to do those, of course, is to graph. You guys know how to graph lines, so you know it's going to be something like that. So of course it's going to pass the horizontal line test. But not all functions you will know what they look like, so you won't be able to rely on the horizontal line test if you don't know how to graph it. So just to illustrate, we're going to use this function, okay? So we want to show that if f of A equals f of B, that implies A equals B. So f of A is 4A plus 20. F of B is 4B plus 20. So now if I solve that, right, I'm left with 4A equals 4B. Divide both sides by 4, so A is B. So I have shown it. So your answer would be yes, this is a one-to-one function. Okay, another one. All right, we'll take a look at number 19 in your book. Y equals the square root of 36 minus x squared. Okay, so we're going to do that just like we did the other one, okay, whereby we plug in A and B and see what happens. So we want to start with f of A equals f of B, okay? So we plug A into our function, we plug B into our function, and then we go about solving. So we're going to square both sides. We get 36 minus A squared equals 36 minus B squared. The 36 subtracts out, and you can divide both sides by a negative. So what you end up with is A squared equals negative B, A squared equals positive B squared, okay? So clearly, we have shown that this is not one-to-one because A is not equal to B. Sure, A squared equals B squared, but see, A doesn't equal B. If you take the square root of both sides, it actually equals plus or minus the square root of B squared. So A is plus or minus B. So everybody clear, A does not equal B. It equals, or it doesn't only equal B, it also equals the opposite of B. So that's not a one-to-one function. Okay, and so to find an inverse of a function, once you determine it's one-to-one, you can then go about trying to find its inverse, okay? So to find inverses, you just basically send a point A to B, and then take the inverse by sending B back to A. So let's say I have a function f and a function g. If I have a point x in here, then my function f carries x to, and why don't we, instead of using x, we'll use a, just to use the same terminology as we did a minute ago. It doesn't really matter which one you use, but we'll use a. So let's say f sends a to point B, all right? If g is in fact the inverse, then it's going to take B and send it back to A. So F and G are inverses if they undo each other. So here we go. So inverse functions undo each other. Okay, so an example of that would be number 38 in your book. It gives us x and f of x, and they want us to find the inverse and see if it matches the other function given. So we have -2, -1, 0, 1, 2. The other problem, let me erase that stray mark right there. Okay, the other part of the table there is -8, -1, 0, 1, and 8. And the other function g is given by 8, 1, 0, -1, -8, -2, -1, 0, 1, and 2. Okay, so here's my function f, right? Here's my function g. If they are inverses, then they are going to undo each other, meaning that if f, right, sends -2 to -8, then g is going to send that back. So you find -8 right here and see, does it send it back to -2? No, it sends it back to 2. So then we would say that they are not inverses. For them to be inverses, they have to undo each other in the manner that we talked about before. So, you know, if you can find a point in those tables that doesn't result in an exact transpose of the ordered pair, then it's not an inverse, okay? So again, you swap ordered pairs. So kind of looking at it then in concrete terms, you would just note that if AB is a point on F if G is its inverse, B comma A is a point. Okay, so what that means is all you have to do to find an inverse is swap ordered pairs. So it's easy enough. So if I gave you, you know, like a table and it had 1, 2, 3, 4, 5, 6, if I asked you to find the inverse, all you'd have to do would be to swap them, right? 4, 1, 2, or 5, 2. 6, 3. So notice you just swap ordered pairs. So you're going to swap ordered pairs. So swap the x and y in ordered pairs to get the inverse. Okay, and so here we're going to take a look at number 42 in your book. And it wants to know if f of x is 3x plus 9 and g of x is 1/3 x minus 3. The question is decide whether they are inverses. So are these inverses? Okay, so if only one-to-one functions have inverses, clearly we're talking about lines here, so they are one-to-one. To find out if they are inverses, remember they have to basically undo each other. So remember the diagram from earlier where if F sends A to B, then G has to send it back, right? So here, we use composition notation, so we must show that f of g of x is x, and g of f of x is x. So it's helpful to look at that. This is called composition notation. But we translate that composition notation into function notation just to make it a little bit, easier. Okay, so this f of g of x is the same thing as this. And g of f of x is here. So notice, first of all, you're replacing, get a different pen color here. You're placing your function g inside of f, and then in the second step, you're replacing x in your function g with f. So we have to show two things, all right? So let's do that. So the first thing we're going to show is right here. So f of g of x means that inside of our function f, we're going to replace x with g. So basically, I'm going to take this and put it inside and see, does it equal x? So we have 3 times 1/3 x minus 3 plus 9. Okay, and then you distribute here. And so 1/3 times 3 is just 1. 3 times negative 3 is negative 9. So negative 9 plus 9 here. And we have the x from right here, right? So we have x minus 9 plus 9. So yes, that's x. So we're good to go, that first, to satisfy that first requirement. The second one that we have to show is g of f of x. We have to show that that's x. So what we're going to do then is identify our function g and replace x with f and g. So here we're going to take this 3x plus 9 and put it inside of our function g. So we have 1/3 times 3x plus 9 minus 3. Okay? Then we simplify. So 1/3 of 3, of course, is just x. And then 3 goes into 9 3 times. So we have x plus 3, then we have this minus 3 on the outside, and that equals x. So the answer to the question, are these inverses? You would say yes. So if these had turned out to be anything but x, your answer would have been no. All right, one more problem, and then we're done with this section. We're going to take a look at number 62 in your book. Okay, so number 62, we have f of x equals negative 6x minus 8. Okay, and it says that this function is one-to-one. Write an equation for the inverse. So basically, we need to swap ordered pairs, okay? So they want to know, what is g of x? Okay, so remember, if f sends a to b, or in this case x to y, g is going to send it back, okay? So what we're going to do is we're going to swap x and y, and then we're going to solve for y. And then we want to use function notation. So kind of 3 little steps there. So here I start with y equals negative 6x minus 8, right? So what I'm going to do here is swap those two. So y is going to become x is going to become y. So that's your first step. Once you swap x and y, you're going to solve that resulting equation for y. So you want y all by itself, everything else gets shifted over. So first of all, I'm going to add the 8 to the left, and then finally divide both sides by negative 6. So you have negative 1/6x minus, and then 8/6 is just 4/3. So that's step 2. Step 3 is just to replace y with function notation. So your final answer would be f of x equals negative 1/6x minus 4/3. And you're done. Okay, and that does it for section 4.1.